students from Edwin Allen High, Yuatan High, Manchester High. Students would have been participating for the past 2 weeks, and we are now in our third week. Our presenter for this afternoon is Dr. Victor Job. He is one of the lecturers at the University of the West Indies Mona campus, Faculty of Science and Technology, he's specifically in the Department of Math. So as I would have been sharing over the past couple of weeks, if you are interested in attending UWI, then who knows, maybe Dr. Job will be one of your lecturers. So you are now having that intimate conversation with Sir, as he takes you through patterns, series, sequences, which is normally question number 7 on the past paper question. So you know we would have started with geometry and trigonometry or the very first week. Last week, we looked at algebra relations, functions, and graphs. Today, we are looking at patterns, series, and sequences. And on Thursday, we will look at measurement. So I'm going to hand over to Dr. Job now. Dr. Job, they are able to open their mics and speak with you so you can have that intimate conversation with them. They also can type it in the chat. And let us remember that we are all live stream on YouTube. So just in case, sir, looked at a part of the question and you didn't catch it right, you can go back to YouTube, Region 7 Mathematics Team, YouTube channel, and you're able to view the recording. Over to you, Dr. Job. All the best, students.
Thank you, Mrs. Johnson-Burrell. Thank you for the introduction and the information. And welcome, students. I hope that that this session would be an interactive one. I am seeing the participant list, and I'm happy to see that it's growing. So if I throughout this session happen to call your name and stuff like that, don't feel that I'm picking on you. I'm trying to learn from you just as much as you hopefully will learn from me or learn from our interaction in this session. All right, so if you have any questions, if you're eager to answer any of the questions and stuff like that, you just feel free to you can raise your hand, you can unmute your mic, you can use the chat to answer the question, just to participate, and let's have a good time here. All right, so before we get into the preparation session itself, I know that our numbers are growing, but just to break the ice a little bit, I just want to throw out a question here. Right? I don't want to start by calling names one by one or anything like that, but I just want to hear just name one thing, if anything at all that comes to your mind, that you like about maths. Anything at all. What do you like about maths? You can put it in the chat. You can put it in the, you can open your mic, even better. Just share with us. Anything you think about. What do you like about maths? Don't all rush at once. I'll give a little time just in case somebody's typing in the chat. Just one thing, anything at all.
No, not seeing any responses in the chat, Dr. Job.
No responses? Oh boy.
Students, remember you can unmute. Feel free to unmute yourself, okay?
Feel free. Anything at all. All right. I hope it's not that people are tired out for the day already. Okay, so maybe I can start by sharing what I like about one thing. There are many things that I like about maths, but one thing that I like about maths is something called approximations. Now, that's not in itself something that's in your syllabus, not directly, but funny enough, it has something to do with sequences. All right, so if there is one thing in the beginning of this session before we even start that you might not have heard before, is approximation has something to do with sequences. All right. So later on, you can think about that. What does approximations have to do with sequences? All right. And what does that have to do with maths? Just bear in mind that what you are doing now in your CSEC exam preparations are going to take you right through to different areas of your life. You might not see it now, but they are going to come in handy in one way or the other. All right. So what I like about math is what? Approximations. All right. So approximations have something to do with sequences, which is one of the things that we're going to talk about. All right. And we actually, when we get to UE, we talk about something called sequences of approximations. All right. So you will hear things that are connected to that. All right. But before we get there, let's see if we can go through some questions just so that we get our feet wet regarding one of the past papers. So let me see if I can switch the slide. It was sleeping for a little bit, so I had to wake it up. All right. So let's go into May 2019. So we're selecting some of the question sevens from different years past papers. So we'll go one by one. All right. And I want to hear from you guys about some of these questions. All right. I want to hear your thoughts, what you guys think could be a way to answer some of these questions. Just feel free to share whatever it is you're thinking about in terms of the questions. All of these ideas are welcome. All right. So May 2019, all right, which is all of these papers are within the last, well, less than 10 years. So they are all relevant to your preparation. Seeing somebody in the chat. Good evening, Rihanna. So you're saying one thing I like about maths is that it gives you the ability. Wow, that's deep. You don't even realize how deep that is. It gives you the ability to think. Wow. Yes. And that is absolutely right. And you know, the more that you do maths is the um, more and more you start to think about whether what people are telling you makes sense or not. All right. So the more you learn about maths is the more that you start to question, right? Not that you're doubting necessarily, but you're starting to question and evaluate. Is what this person saying true? Does it make sense when somebody's giving a speech or talking about something and giving me some kind of argument? Is it something that's sensible? Is it something that's something that I can take something from? What can I take from it? What can I look more into in order to understand more about it? But yes, so that's one of the things. Thank you very much for that contribution. All right. And as we go through, even if you think about something as we go along and you want to share it in the chat, something that you like about maths, you can still feel free to share it. All right. Okay. So let's go on to the first set of questions. All right. So these would all be question 7 related content. So that would be based on sequences. We take different samples from different papers. All right. So let's start with the first question, and I'm going to read it. All right. At least the first part. All right. Which is part A, which says the nth term, and the nth term, which we call Tn, T subscript n, of a sequence is given by this formula. What does the formula say? T of n, or T subscript n, is equal to 3n squared minus 2. All right? So the expression or the formula for the nth term of this sequence is given by 3 times n squared. All right? And then you subtract 2 from it. All right. So the first question, which is part 1, and we'll take it one by one. All right. First part says, show that the first term of the sequence is 1. All right. So I'm seeing another response in the chat. Oh, that's Mrs. Johnson Burrell. All right.
Yes, sir.
Oh, that's a very good idea. You know, I was actually thinking to ask that. But that slipped my mind at some point. Yes. So everybody, which school you come from? Which school do you attend? Type the name of the school that you attend in the chat so that we could know. All right, and I would like to hear about that. What type of greatness do I have among us? All right, Edwin Allen. All right, Edwin Allen High School. So we have three from Edwin Allen. Okay, Eltham High School. Okay, Gavi. All right. All right. So I'm seeing a pattern here. No pun intended. I'm seeing a pattern. Could somebody tell me what the pattern is? I'm seeing a prevailing pattern in terms of who's here. Not fully, but I'm seeing Clarendon College. I'm seeing how do I pronounce Den? Is it Denby?
Denby High.
Denby High School. All right. Good. All right. So I'm seeing two Denby High Schools. I'm seeing um let me see if I'm seeing any other patterns here. Um, in terms of repeat patterns. All right. And then I'm seeing a large cohort of Edwin Allen High School participants. So there is greatness among us, which comes from the different schools that you attend. And there's even great those who are not yet here, but I'm hoping that they are fast approaching to join us. All right. And also, I'm sure those of you who are listening or will be listening on YouTube would also um, appreciate the schools that you come from and really appreciate the things that you would be learning and would have learned so far in your schooling. All right. So I'm seeing Vauxhall High School, another Edwin Allen, lovely. All right. Okay, good, good, good. So we have the sampling of the schools here. All right. So I'm going to do some statistics on this when we're finished. Well, perhaps. All right. And see if I can identify some type of pattern and trend in terms of the school participation here today. All right, but first, before I get ahead of myself and go completely off track, let's get back to what we were talking about. All right. So the nth term of the sequence is given by this formula. Tn is 3n squared minus 2. The first question is, show that the first term of the sequence is 1. So you're already given in this question, to get your feet wet, you're given the answer to the question. It's just a matter of verifying that what is being said here as the term of the sequence being 1 is actually true. All right. So could anybody tell me how we would go about doing so? What can we do with this question in order to show that the first term of the sequence is 1? Don't all rush at once.
Sir, replace the n with 1.
Replace the n with 1. Hold on. Let me see our next slide there if we have something like that. All right. So replace the n with 1. All right. And if you do that, could somebody walk us through a bit of the calculation? So who was it that just spoke there? So I could get a sense of who we are. Could you just tell me your name? I didn't quite see who unmuted at the time.
Sir, Javier.
Javier? All right. So good. All right. So if you walk us through, or maybe another one of you can just walk us through, how do we um actually do the calculation in order to get this done? I want to make sure that everybody is okay with the calculation. All right. So could I get another volunteer to walk us through? All right. How we get the value of the first term of the sequence? Let me see if I could write something as you tell me about it. So what are you substituting? N as what?
1.
N as 1. All right. So if you substitute N as 1, what would we get? So what is the calculation that we're going to get here? Anybody? So by substituting N as 1, we're going to get T1. That's fine. All right. That would be the first term, T1. So what am I plugging in? Plugging in
6.
n into what?
3.
3. Good. What's next?
1 squared.
3. And is that plus 1 squared? What's the operation? What am I calculating here?
Bracket.
3 bracket, okay. Which means multiply, right?
Yeah, 1.
Okay. Like
Squared.
this?
Yes.
Okay, so 3 times 1 squared. So the 3 is not being squared, right?
No,
No,
sir.
sir.
Okay. I'm worried about that, because sometimes us UE people make mistakes and put the 3 being squared as well, right? So I just want to make sure that none of you end up doing that, right? So unless you have a bracket around the 3 and the n, both of them, and then it says squared, you're not supposed to square, right? You're not supposed to square the 3. Good? So it's the 1 alone that you're going to be squaring. So when you say 3 times 1 squared, all right, you're taking the 1, squaring that first, multiplying by 3, and then when you finish with that part of it, then you say minus 2. That makes sense? That's all right?
Yes,
Yes,
sir.
sir.
Yes, sir.
Okay, we're good with that then. All right. Let me see something. I decided to write on the screen, but I forgot how to erase it. All right, because I have the working, I should have the working already. So I just wanted to write a little bit. All right, so everything checks out. And I thank you guys for that assistance. All right, so when you say the first term of the sequence, you substitute the n value in that term as 1. So you get T1, which is, and I put it a different way instead of the bracket, but the bracket is okay, right? To say bracket and then you say 1 squared, all right? But I put it a little differently using the x, but you don't have to do it like that. But you say 3 times and you say 1 squared and then minus 2. Bear in mind that you square the 1, that's the first operation that you focus on, all right? And then you do multiplication. 3 times 1 is 3. And then when you finish with that, you do the subtraction. 3 minus 2. And then you get 1. All right? So that's okay for everybody? Any questions? Everybody comfortable?
Yes, sir.
All right.
Yes, sir.
Okay. Good. Great, great, great. All right. So there's another part of this question. All right. And I put it here. The question asks now, part 2, what is the third term of the sequence? So it doesn't tell you what the answer is this time, all right? But it's the same kind of concept. What do I have to do in order to get the third term of the sequence? Anybody?
You would let n equal 3.
Let n equal 3. All right. And so if you let n equal to 3, I'm going to give you guys about a minute. All right. If so much. And I want somebody to tell me the answer. I'm hearing, I think it's, how do I say it? Biana or Brianna? You were cutting out a little bit. I don't know if it's my internet. Could you repeat what you said? Or maybe it's my internet. Or if you want to type it in the chat. I didn't hear you.
Sir,
Yes.
sir, so me that, but just come in, sir. So me that say, if
Hmm.
I use the opposite, I take away that, I think I add, that I add them, sir. I know that.
Okay. So repeat that again for me. So if I want the third term of this sequence, this is the one you're talking about, right?
Yes, sir.
Okay.
You know
So
the
walk me
opposite,
through again.
you know the opposite, I take away, right?
The opposite of takeaway, sir?
Yeah, that addition.
For which one? Where are
Um,
you seeing that? I'm not too sure.
for the term of the sequence.
For the term of the sequence. Okay.
Yeah.
Well, what I would say to that is that we follow the formula, all right, more than anything else. So if we're asking for the third term, given the nth term, then it's really a matter of identifying what number to put for n, and then that tell you what to substitute.
Oh,
All right.
yes,
So
sir.
it's not necessarily about subtracting or add per se. It's just about saying if you're
The
given a
final
formula,
sequence.
you
Yeah.
just plug in the value and then make the calculation. All right.
Okay, sir.
So in that case, if you say third term, what n value you think you're thinking about?
Sir, 3.
N is 3. Okay, good. All right. And so by taking n equal to 3, all right. So we have a lot of trees now, not trees like the one that we plant, all right. But we do the calculation, all right, which would appear something like this. So very similar to what we were doing. I'm seeing a message in the chat. So Kim, you say you got 25. Lovely. I got 25 as well. All right, let's see how we did the calculation. So Kim,
Oh, 3 times 3 square. Take away 2 and 3 times. Oh,
right, you see it now?
yes, sir.
All right, so you just observe the formula,
Oh,
right? Which give you the formula is 3n squared minus 2. And you just observe that formula and say, okay, the third term of the nth term in general is obtained by taking n equal to 3 and plugging that value of n into it. All right, good. So it was Kim who said that that 25 is the answer. Could you just walk us through that a little bit and tell me if there's anything that you did differently than what I have on the screen? So what I did is shown here, right? But I just wanted to know if that's what you did, Kim, in getting the answer, or if you did it in a different way, or you looked at it differently. You might want to put it in the chat if you're unable to unmute your mic. But I encourage you guys to unmute though and use your voice. All right,
oh,
so
sir.
just wait a little bit.
Mistake.
Okay,
Mistake now.
so got it. Lovely.
Yeah.
So look like you understood something maybe a little differently now, a little new.
Yes, sir.
All right, lovely. That's what we want from this type of session. All right. So I'm reading what's in the chat from Kim. I did the same thing, substitute n for 3. Okay, I'm just reading from the chat. Then squared the 3. Okay, got it. So, and I'm seeing another response in the chat from Mariana saying the question was approached the same way. All right, so let's take a look. So by substituting n equal to 3, which is right here, what was done is that n, which is 3 now in this calculation, is squared. So you work out n squared as being 3 squared first, all right? And then multiply by 3. So what I have 3 squared is, of course, 9, all right? And then once you're finished with that order operation, all right, then we say 3 times 9, which is 27. So we work that out. And then the subtraction comes after. So 27 minus 2, and that gives you 25. All right. So I think everybody would have heard about being aware of the order in which operations are used. All right. So what do you guys know it as? It should be BOMDAS. Sound familiar?
Yes, sir. Yes,
Lovely.
sir. Yes, sir.
So when we talk about order, the O in BOMDAS, what we mean is power. So when you say 3 squared, that means that is given priority in the calculation over not all other operations, because bracket is the king. You have to obey and respect the bracket more than anything else. That's the B. All right. But after brackets, which we don't have any, at least not directly. We need to respect more highly the order operation, which is the power usage, and then do anything else after. All right. So the order, which is the power, is done first, and then you do the multiplication, which is the M, and then the well, subtraction is unfortunately come last place. All right, that's the S. All right, so that's the last thing when you're thinking in terms of calculation that you should think about doing. So if it's your minus sign, leave that for last before anything else. All right, so 25 is the answer that we got. All right, but the key takeaway here is that we obtain the third term of the sequence by looking at the formula, observing it, and then taking n, which is the nth term, as 3 to give you the third term of the sequence. Any questions here? Everybody's okay?
Yes, everybody.
Yes, sir. Okay.
You're good? Okay.
Yeah.
Cool. So what's next? Let me see. Hold on. All right. So the third one now. Now this one here is a little more involved. All right. Not too complicated, but you have a bit more steps to do. All right. So the question says, given that, all right, somebody read this question for me, if you can.
Given that Tn equal 145, what is the value of n?
Given that Tn, all right, so given that the nth term of the sequence has the value, when the calculation is done, you get 145. It's almost like you're asked to work backward to figure out what n needs to be. All right, so what the question is asking is, what does n need to be in order for the nth term to be 145? All right,
Sir,
so
sir,
yes,
sir,
Jalix.
so what me there, sir? So first, you have to set them equal, though, sir.
Right.
Yeah,
So you set them
that's it.
equal. So you have the expression for Tn already, right? That's up here.
Yeah, yes, sir.
3n squared minus 2. So you set that equal to what?
You set them equal, add 2 to
45.
both.
Lovely. Lovely, everybody. 145. Okay. So you set them equal to 145. And what do you do next?
Yeah, add 2 to both sides.
Okay. You can add 2 to both sides. All right. To cancel. All right. So that's a good step-by-step approach. All right. Can we take about a minute just to, I want you guys to try this out before I show you the solutions. All right. So try this out and tell me what answer you get. All right. And I want a volunteer or maybe 2 volunteers or maybe 8 of you to tell me what the answer is going to be. All right. So let's take 2 minutes. All right. To work out this value of n.
Say n equals 7.
Any questions already?
Sir,
Oh,
yes, sir. Any equal 7.
people work
Because
fast though.
147 divided by 3 are 49, and they are finding the square root of 49, and it will give you 7.
Hey. All right, you guys are sharp. Oh, okay. All right, so I'm just looking at the chat and I'm seeing sevens. Okay, so everybody is consistent. You got a value of 7. All right, I hope I got 7 as well. Let's see what happened now. Anybody still working on it? Just want to give people time to try it out. All right, so I'm gonna just wait another maybe 30 seconds or so, just to give you guys time to work it out. All right, those of you who may not have gotten the answers yet.
Sir, so I
So
will now win this online sitting I will keep, sir.
when the next time?
Yeah. Yeah. Tomorrow?
Okay, so the next time would be Thursday. All right, so
Okay.
Mrs. Johnson Burrell had mentioned that earlier. I think you had come late, so yeah, so I just answer
Yes, sir.
that question today. Yes, so I think that would be measurement that would be done in that
Okay, sir.
that would be the last session.
I'm kind of
All
fluent
right,
in
for the
measurement.
for these preparation sessions.
Yes,
Sorry?
sir. No, I'm saying
Repeat.
I'm kind of I'm kind of fluent in measurement.
You're okay. You're okay with measurement. Okay. I mean,
Yeah.
you might still learn something, you know, so you can still attend. Please still attend it and see
Yes,
what
sir.
you'll learn something out of it, or you might see something a little differently. You never know.
Yes,
All
sir.
right.
Yeah.
Okay. So let's see if I have gotten something like 7 for this question. If me get okay, I'm glad that I actually got 7 because I'm trying to one. I'm worrying now if I could run
Yes,
with you
sir.
guys. All right,
Yes,
because
sir.
you're going very quickly.
Yes, sir. So
All right. So
mhm.
tell me about this now.
So it's a 3n take away 2 equal 145, and then it's a 3n equal 145 plus 2 equal 147, and it's a n square equal 147 over 3 equal 49, and then it's a n equal square root of 49 equals 7.
Okay, good. All right. So because n squared is what you get as 49 when you simplify, when you do the division, then n, and bearing in mind that n is understood as being a positive number. All
Yes, sir.
right? Positive, or let's say something like a whole number. So you don't expect negative as the answer. All right, that's the understanding when you talk about sequences. All right, I'm just talking generally for everybody. All right, so the understanding for sequences is that you wouldn't take the negative, because remember, when you take the square as being 49, technically when you solve it, you're supposed to get what? Plus or minus 7? Anybody know about that?
Repeat.
So when you
Yes,
get
sir.
square is 49, there are two things that could square to give you 49. You could have 7 squared is 49, or you could get negative 7. When
Yes,
you
sir.
square
Yes,
that, you
sir.
get 49 as well. Right?
Yes.
So what I'm saying is that the understanding, when you talk about sequences, I'm just giving a general comment. Right? When you talk about sequences, you do not consider negative numbers for n. All right? So the terms are whole numbers. Let's put it that way. Whole positive numbers usually starting from 1. When you count, when you like you're counting 1, 2, 3, etc. When you talk about the term of the sequence, all
Yes,
right.
sir.
So when you take the square root, you don't consider the negative square root. All right, only the positive. Good. Make sense for everybody?
Yes, sir. Sir, yeah, so many do it, sir,
Yes.
but they get negative 7, but my dad say, negative 7 cannot be 9, so I just say 7.
Right, right. So that's because the understanding is that you're taking positive whole numbers. All right, so
Yes.
you don't consider the negative when you say a term of a sequence as an as a value of n. All right, because that would mean if you say negative 7, that means you're saying the negative 7 term, which strictly speaking would not make sense
Yes,
based on the
sir.
understanding. All right.
Yeah.
Okay, so everybody's okay with this? Anybody has any questions about any part of this working?
No, sir.
Straightforward to everybody?
Yeah.
Yes, sir.
Okay, all right. So this would have been part 3 of this question. That means that there is a part B of this as well. Let's take a look. So let's move over. Oh, okay. So in part B, we switch over to give you another sequence now. All right. So let's take a look at this. Let's see if we can break this down. I wonder if I have a more cut down version of this. Let me see. Right. So, okay. So I'm dealing with this part by part. So before you go to answer the question, and this is a recommendation, this is what I'm saying to everybody, read the question properly. All right. If you don't know what the question is asking, then you would
Yes,
not
sir.
know what you're answering. All right. You may not answer the question unless you read the question properly. Right. So even if you're rushing and you think, oh, I'm going to run out of time, make sure that you understand what the question is asking first. Take that few seconds, those extra seconds to read the question properly. All right, so that you know what instruction to follow. All right, so that's a general statement for exams. Good. So in part B, the first 8 terms of another sequence, that means different from what we just talked about, right? With nth term, we're calling this now UN. We use a different letter just to say it's a different sequence. Good? From what we just spoke about in part A. Good? So the nth term, or the terms of this sequence, at least the first 8 are, and we have the list of the first 8. So let's see, 1, 1, 2, 3, 5, 8, 13, and 21. That sounds like 8 numbers to me. All right. Now, to help us out, we are given a formula for some of these terms. All right. So we are given, so sometimes, by the way, we have a notation with a subscript, meaning U, and then the N sometimes goes to the bottom. Right? You would notice that here. Sometimes the N goes to the bottom as a what you call a subscript to say the nth term of the sequence, which we call U subscript N. But sometimes we write it as U of N. All right? It means this, it represents the same thing. That is the nth term of the sequence. All right? So don't get bothered if you see 2 different representation of the same thing, right? It means U of 1. When we say U of 1, that means the first term of the sequence. All right? So when we say U of 1 is 1, that means that the first term of the sequence is what number? Somebody tell me the answer. The first term is 1. All right. So when I say U of 2 is 1, then what term is that? The what term? The what term is 1?
The second term.
Second term is 1. Lovely. And so to extend it, which is what the whole idea of patterns is all about, by the way, in order to extend this idea to say 1, and then the second term is this, the third term is whatever, the fourth term is whatever it happens to be, right? We can identify a pattern in the way that the terms behave. And in this case, we say that U of N, I'm reading the line that goes after and, right? U of N, which means the nth term of the sequence, is equal to U of, notice the brackets, you have to respect the brackets, U of N minus 1. Everything is in the bracket there, has to be respected together. N minus 1 means the N minus 1th term of U. All right? And then U of N minus 2 means the N minus, I guess, N minus 2nd term of U. All right? So what does this formula mean? What does it tell us? That means that the nth term of the sequence is dependent on the previous 2 terms. The terms 2 steps behind it. All right, that's what this formula is telling you. That the nth term of the sequence is the sum of the previous 2 terms of the sequence, which is the n minus first term and the n minus second term. All right, that makes sense? That's how we read it. Any questions about it? Not sure? If you're not sure, you can let me know, you know. That's no problem. Because we want to clarify, make sure that if there is something that you're not too sure about, maybe it can be repeated. We can talk about it a little bit, no problem. All right, so let's see. I'm seeing something in the chat. So Rihanna is saying that you're lost. All right. Okay. So are you lost particularly about this question, or were you lost with the last one? As in with part A. I want to know at what point you had gotten lost. And Jaden, you got lost with this one. Okay. All right. So I think first of all, maybe the terminal, the notation in the first line should be U of N, right? U with brackets N. But anyway, we won't worry too much about that. Just looking back in the chat again. All right. So Right. So Chris is also saying lost with this one. All right. So this sequence here, all right, has a certain, the form of this sequence has a certain name. We call it a recursion. I don't know if you guys ever heard about that, but it's the name of it isn't that important, but it's something that you should know about, right? That or would have heard, should have heard about maybe at or will hear at some point. So when we say u of n, first of all, let me just focus on this part right here. All right, u of n. That means the nth term of the sequence. Everybody follow that? Especially those who said that they're lost. Just follow me step by step. So when I say u of n, all right, I'm saying the nth term of the sequence. Everybody's okay with that? Or those of you who are lost so far, okay with that, with what I just said? Just make sure
Yes,
we get
sir.
a baseline. Okay. So u of n means the nth term of the sequence. Okay. When I say u of n minus 1, what do I mean? It's almost like I'm saying n is being replaced by n minus 1, meaning in the placement of it, of the positioning. Instead of n, I have n minus 1. So that means that this is the n minus first, meaning the one before n. The number before n is n minus 1. So that means the positioning in the term is the position before, which means when I say u of n minus 1, I mean the n minus first term of the sequence. All right? So maybe I can give you a little illustration in terms of calculation in a little bit. All right? That might help you out a bit in terms of understanding what this is saying. All right? U of n minus 1 means the n minus first, all right, term of the sequence. All right? Everything in brackets tells you what term we are, what position in the sequence we are at. All right? So those of you who are lost, let me make sure that I try to get you back on track. Do you understand where I say that n u of n minus 1 means the n minus first term, meaning the term before the nth one? You guys follow that? Or not too clear about that? Just let me know.
Sir, so the term n take away one is so they're taking away like the n that's in the un, if I'm making sense.
Well, okay, I think I may understand what you're saying. Hold on. Just give me 1 second. Let me see if I could clarify that. Hold on. Where is my thing to erase? There is a difference. I think what you might be, correct me if I'm wrong. What I am hearing you say is this. Is that what you are saying?
Yes, sir.
Right. So we come back to BOMDAS, where the bracket, sorry, must be respected. So when you have a bracket, you cannot go past the bracket so easily to say you're taking out -1 from it. So what I mean by that is this is not the same as saying u of n minus 1. All right? So n minus 1 tells you what term we are at. So let me give you an example. All right? Maybe what might be helpful is for us to do some calculation with this sequence before we go on to the other workings that we have to do. All right? Right, so there we go. So if I take, notice here that this formula, which we'll try to understand a little bit more, all right, is for n greater than or equal to 3. All right, that's something to bear in mind first of all. Just looking at you guys in the chat. So I'm seeing Kim saying, hold on, I just lost that thing there. If it is 7 term, n minus 1, right? Yeah, you're correct. So you got it. So n minus 1 would be the term of the sequence, would be 6, right? Would be the term before All right, it's not that it's one less than the previous one, but it's one position behind the previous one. Anyway, hold on. Let me just give you some examples of this. All right. So this formula that is here is valid for n greater than or equal to 3. All right? Which means, what is the smallest n that this would work for, that this would be valid for? If you say n greater than or equal to 3, what's the smallest n that this formula would make sense for? Could anybody tell me? 3. Okay, good. So now, let's take a look at this now. Based on the formula, if I put n as 3, this tells me that u of 3 is the same as what? U of, what's n minus 1? If n is 3, what's n minus 1?
3 minus
3
1.
minus 1,
Which is, what
2.
number?
2.
2. So u of 2, which means the second term of u, plus what? What's n minus 2 then? U of? So
3
n minus
minus
2
2,
is?
which is 1.
3 minus
Right.
2 is 1.
So u of 3, which means the third term of the sequence is equal to the second term of the sequence, which we have already. That is 1 plus the first term of the sequence, which is 1. All right, and we know that 1 plus 1 is equal to
2.
2. All right, I'm asking you foolish and simple questions, right? Okay, so I want to establish the baseline to make sure that everybody's okay. All right, so u of 3, which is the third term of the sequence, can be calculated using the previous position terms of the sequence, the previous two, which are u of 2, the second term, which we are given here as being 1, all right? And the first term, which is given here as being 1 as well. So the first term and the second term are the same, all right? But based on the first term, which is u of 1, being the same as the second term, which is u of 2, we calculate, using this formula, we calculate the third term as being the sum of the first two terms, which is 1 plus 1, giving you 2. Which is what we have up here, by the way. We just illustrate it. Right? So the third term is, or has the value of 2. All right? Everybody follow me up to this point with that calculation? Any questions about it?
No, sir.
Yes, sir.
Very good. Especially those of you who said you're lost. I understand that you might not be fully there as yet, but I want you guys to follow along with me so far. All right? Okay. So if I do the same thing for the next n, which is what? So I know so far about the first, second, and third terms of the sequence. Can I do the same thing for the next one, which is the fourth term of the sequence? Let me see if I can do something similar. Oh, I wonder if you guys can see that. Hold on. May not be able to. Hold on, let me see something. Can I erase that previous one? All right, hold on, 1 sec. All right. So let me try again with that now. Okay. The next term of the sequence would be for n equal to what? Oh, and the question, one sec, I'm just seeing in the chat, a question is here. How can I tell? How can I tell? Okay, so you want to know, how do I know what calculation to make? So I want to find out as many terms of the sequence as possible. Most of the times that's what we want. The more information we have, the better. All right. Now, the thing is that because this is a sequence which naturally counts the terms as 1, 2, 3, 4th, 5th, 6th, 7th. All right. If I know the first and the second, the most natural thing to want to know is what's the next one, which is the third. So that's how I know to find out for n equal 3, because I don't see on the paper what the third term is yet. So I use what's on the paper, which is the formula up here, all right, to calculate the next one, which is u of 3. That's what we just did, and we got the value is 2. U of 3 meaning the third term of the sequence, all right? So the next natural question to ask is what is the next one? What's the next one being what? N equal? N equal what?
4.
4, right? So I want to know u of 4. One sec. Yeah. 4. How do I calculate u of 4? I have a formula already, which tells me that when n is equal to 4, all right, I can calculate u of 4, which is the fourth term, by working out the sum of the previous two terms, the last two terms back behind it, which is u of n minus 1, which is what now? What is n minus 1?
4 minus 1.
Which is 3.
3.
So u of 3, all right, which is different, by the way. It's different from u times 3. It's u of 3, all right? That's a little different. Plus, what's this? The terms 2 back from that. 4 minus 2, which is?
2.
Right. Good. So u of 4, which is the fourth term of the sequence, is the sum of the third term and the second term of the sequence, which we know information about already. What's the third term? We just calculated it, which is? What's the number of the third term of the sequence? What value does it have?
2.
2. All right. Plus, what's the second term? We were given that in the question itself as u of 2 equal what?
1.
1, and 2 plus 1 is?
3.
3.
3. Lovely. All right. So where does that come into the picture? Isn't that the fourth value in the list? Just underline it, right? So that's the fourth value in the list. All right. So that is what I call the fourth term of the sequence. So Kim is asking, what if I ask what is the 15th term and it's not listed? All right. So the thing about this type of sequence is that you cannot calculate, you can't skip ahead, too far ahead to calculate a large position, a far along position. So it's not easy to calculate the 15th term. It's possible, and it just takes a little time to do it. But in order for you to get the 15th term, you have to calculate all the others up to 15 first. All right? So to get to the third, you needed the second and the first. That's what we did first, right? That's what we did in the first calculation. All right? To get to the fourth, we needed the third and the second terms, previous two terms, calculations. All right? Now, to get to the fifth, you need to calculate the previous two, which would have been the fourth term plus the second, right? Which would have been 5 plus, look up here now, 5, where is it? 5 plus 3 equals 8. Right? To get to the next term, you need 8 plus 5 equals 13. To get to the to get to the next one, you need 13 plus 8 equals 21. And then the next question now is how do we get to the next one after that? You do the same calculation, but for different values of n. And that's what part 1 now asks you to do. That's where we are at now, where part 1 asks you to write down the next two terms, which are what? U of 9 and U of 10. That's where we're at now. All right? Okay, so anybody has any questions about U of 3, U of 4, any of those things? Any queries? Anybody less lost? Not as lost, hopefully? Let me see who's not as lost in the chat. Or even if you're still kind of lost, you just let me know and I'll look out for you in terms of the other calculations. Still a little lost. All right. All right. No problem. So when we're doing the answering the questions now for part 1, part 2, etc., let's see if we can apply this idea that we just started to speak about. And then from that now, hopefully we get a bit more understanding by working and by doing. All right. So what I'm going to do next, because we have a lot of clutter on the screen. All right. We still have the opportunity to do our calculations. All right. But I'm going to have to erase to kind of clear this up a little. All right. So what we are, let me just take a look in the chat again. All right. Still at a loss. All right. No problem. When to use the substitution. All right. So the same way that the previous question asks you, what is the third term? And you know from that n is 3. All right? Or when they ask you about what the first term is, you know that means n is 1. First mean 1. All right? In the same way, by what the question asks you to do, you have 9, then that means that you can use the calculation when n is what?
9.
N is 9.
9.
All right. So it's just a matter of you knowing that when n is 9, n minus 1 is what?
8.
8.
And n minus 2 is the one before it, which is
7.
7. Good. Right. So once we know this, then to get u of 9, we calculate u of 9 equals u of what? What do I put in the brackets?
8.
8.
8.
All right. Plus u of
7.
7.
7. No, this is where our counting skills come into the picture because we already know the first 8 terms. That's what the question told us, right? The first 8 terms are listed. So we just have to know where to identify the position. So that will help us to go forward in getting more terms of the sequence in the list. All right? So the 8th term is the last number in the list that we have above. What's the last number?
21.
21. And what's you have 7 then? The second to last one, right?
13.
Which is 13. Good. And what's that number?
34.
34.
34. So now that we know that the 9th term is 34, we have extended the terms of the sequence in terms of what we know from 21 to be in the next term, which is 34. All right. So now the next thing for us to do, which is what part 1, question 1 tells us to do or asks of us to do, is to write down what? You have
10.
10.
So you have 10.
10.
So you have 10
E.
means that n is what?
10.
10. So when we apply the formula, which is this formula up here, all right, then u of 10 is what? U of
9.
9.
9,
Of
which we
8.
just calculated, plus
U of 8.
U of 8.
u of 8. Lovely. All right. So we know u of 9, right? What's u of 9?
34.
34 plus what's
21.
u of
21.
8? 21. All right, and the numbers are getting bigger. So what does this work out to be now?
55.
55.
Lovely. I like the participation, guys. I really appreciate it. All right. So you guys are engaged and you guys are learning. All right. So the more that you guys speak is the more that you guys learn and the more that you guys prepare. All right. So good. All right. So we know that u of 9 is calculated as 34 using the previous two, which is the 8th term and the 7th term. And then u of 10 is calculated using the previous 2 terms, which is the 9th one, which is 1 behind it, and then you have 8, which is 2 behind it. All right? So we just use the previous information, which is for the U of 10 calculation, U of 9, which we calculated before as 34, plus U of 8, which was given to us in the question as, given to us in the question as 21. All right? So that's about it. So for this question, we have answered the question, which is, what is U of 9? We worked it out using the information provided, right? We have a formula for calculating new terms based on previous ones, all right? So U of 8, which is the one before the 9th one, and U of 7th, which is the one 2 steps behind the 9th one. All right? And so that gives us the calculation, 34 for U of 9, and then the next one, we just build on that, 34, which we just calculated, plus 21, which was the term before that one, which is given here, 21. When you add them, you get 55. All right, and that's how we do the calculation. All right. Any other queries here? Questions? All right, so let's move on to, okay, so this is what I would have prepared in terms of the answer. All right, so it's the same calculation. Good? Okay, so this is part 2 of this question. All right. I'm looking at the time, and I want to make sure that we also take a look at some of the pattern recognition questions and stuff like that. All right, so I'm mindful of that. So which term in the sequence is the sum of U of 18 and U of 19? So this question here, the trick of this question is for you to recognize what this formula actually does. All right? So remember that this formula tells you that the nth term of the sequence is the sum of the previous 2 terms of that same sequence. So it's 2 numbers back in the list of terms. All right? So if you recognize that any term, let's say the nth term of the sequence, is the sum, which means sum meaning plus, the addition of 2 of the previous terms that came behind it. All right? So the question asks, which term is the sum of U of 18 and U of 19? So the question is asking you to figure out the sequence in a backward way. All right? So we put it like that. All right? So you're really being asked to look at the formula in reverse. All right? And the question is really asking, what does the formula add up to in a way? All right? So what term is in the sequence is the sum, meaning what is the value of n? All right? For which U of 18 plus U of 19 gives you an answer. What would that U of what end up being?
20.
U of
20.
20. All right, so we got it. All right, so it's just a matter of figuring out really what the question is. I could probably imagine that if you look at this question, you may not quite know or quite follow what the question is really asking you to do. All right? But what this question is really asking you is, can you understand what the formula is actually doing? All right, so we know that the nth term is the sum of the previous 2, right? So the question is really asking, what is the sum of the previous 2? Equal, right? So U of 18, that looks like the n minus 1. The n minus 2, sorry, right? N minus 2, all right? And then what is U of 19? That's the n minus 1th term, right? So therefore, what is n? U of, and you guys answered already, right? U of, what is it? 20. All right. So that, in a sense, is a pattern recognition type of question as well. All right. But using sequences in terms of that. All right. One sec. Let me see. Just erase some things here. All right. So the answer is given here. So U of 18 plus U of 19. That's basically this formula, but written back way, in a way. All right. So it's written as U of 18 plus U of 19. That will give you, based on the formula, if you write it in, if you replace the left-hand side and the right-hand side, if you switch them around, that will give you U of 20. All right. Any questions here?
So we're supposed to like add instead of take away for this one?
Not really, you know. It's just identifying what value of n fits the formula. If you say U of 18 is involved and U of 19 is involved and you're adding them. So it's really recognizing what n value does the is used in this formula when you say 18 and 19 being added, these terms being added together. So it's really recognizing, it's not really doing a calculation really. It's just identifying what numbers in terms of the terms are involved and what does it lead to. So you have 18, you have 19. If you add them, the formula tells you that what you will get is u of whatever the next term is, which is n equal 20. All right, so that's just a direct pattern recognition of the formula being used. All right, so you don't need to calculate anything other than that.
So like you're counting.
So basically you're counting, yes. Counting, but using the formula and recognizing what the formula is doing. All right, so some practice and seeing this type of question would be very helpful if you see something similar to this. It may not be plus. What if it were another question like minus? It's just a matter of recognizing the formula and what it's actually performing, what calculation it's performing. All right. Okay, so let's take a look at another type of question. All right. I think I'm not going to focus too much about this question. All right. But this one here says to show that, this is basically a verification question. Show that u of 20 minus u of 19 is equal to something else. So show that the left-hand side gives you the right-hand side, basically. So what you do is that you just use the formula, right? When n is equal to 20. And what you will notice is that for u of 20, I'm going to see if I could highlight some things here just to illustrate quickly for you. U of 20, using the formula here when n is 20, I substitute this as u of 19 plus u of 18. All right? Minus, so if I want to figure out what's going on with u of 19, I use the formula here again, but with n equal 19, and that will give me the previous two terms being added, which would be u of 18 plus u of 17. That means the 17 term plus the 18 term. All right, and then at that point it's just making use of brackets. All right, bearing in mind that when you have a bracket around two terms, right, the negative sign would have to be distributed when you expand it. So you would have negative, negative, because negative times a positive give you a negative number right here especially. All right, so when you do that expansion, it's just a matter of noticing here that u of 18 is subtracting itself to cancel out to give you 0. And then what you're left with is just u of 19 minus u of 17, which is what they asked you to get in the first place. All right, so it's a little bit of algebra manipulation here being done. All right, and canceling. All right. Okay, any brief questions about this? No questions so far. All right, let's take a look at, wait, I'm seeing a question in the chat. Let me just see here. All right, so no particular questions right now. Okay, so let's take a look at a nice little picture. Let's see if we can figure out something here. All right, so these types of questions here it's very important for you to read it, all right, to understand what is being said. But the tables that are often linked to these questions are very important as well, are very useful, all right, because you would then be asked to fill in certain information in terms of the tables. All right, so let me just read through this. The diagrams below show a sequence of figures made up of circles with dots. All right, so basically 4 points on the circle and a dot in the center. If you add another circle, you would add another 4 dots, all right, around it. And then what you would do is that you shade the outer region and then you leave the inner circle region unshaded. All right, if you add another circle again, So then you put dots on the 4 north, south, east, and west, and then you widen the region that is being shaded to the outer one again. And then keep doing that. So this is a pattern recognition type of question. All right. So every time you add a new circle, you shade the outer region, the outermost one. All right. And then you add dots to the north, south, east, west of the diagram. All right. So this question is going to test a bit of area in terms of area of circle and stuff like that based on radius and those things. All right, we'll get to the table in a little bit, but I'm gonna focus on this part here. Each figure has 1 dot at the center and 4 dots on the circumference of each circle. All right, that's the north, south, east, west. All right, the radius of the first circle is 1 unit. So the radius of this first circle here, 1 unit. All right. The radius of each new circle is 1 unit greater. That means that the radius of the second circle is what? Anybody? So the radius of, could you repeat? Didn't hear you.
2 units.
2 units. Good. The radius of the third circle is what? Of the third figure, sorry. Let's put it that way. Of the outermost circle is what? For figure 3. 3 units. And then the radius of the fourth figure is, the fourth circle is 4 units. All right. So except for the first figure, a portion of the other figures is shaded. All right. So the reason being that we only had 1 circle, so there was no inner circle in figure 1. So that means that was the one that was automatically shaded. But once we had the opportunity of having an outer and inner circle, then it's the outermost region, which is the one out here that is, the one out here that is being shaded. All right. So, all right, let me erase this part here. So now, based on this, on these diagrams, let's take a look at this. I hope that you guys can see this properly. It's a little fuzzy. All right, but that's what happens when I'm being a little lazy and I copy and paste. The quality goes down. All right, so you are asked here to complete the rows in the table below for figure 5. That means the next figure after the fourth one. All right, so the idea is to recognize the pattern. All right, I know sometimes the question can be answered without looking at the figure at all, without looking at the diagrams. Sometimes you can answer the question by looking at the numbers in the table itself. All right, and seeing if we can identify a common pattern in the way that the numbers change. All right, so let's see what we can do with it. Of course, the figures help to reinforce the information that is obtained, because the information here is obtained from the figures in the first place, or the diagrams in the first place. All right, but let's see. So I'm seeing here different columns. Figures 1, 2, 3, 4, 5, and it keeps counting. Doesn't that look kind of like terms of a sequence? So figure number is the term of the sequence. 1, that's term 1, figure 1. 2, figure 2. 3, figure 3. 4, figure 4, etc. And it keeps going down to, generally speaking, N, figure N. All right. Seeing someone in the chat here.
No, sir. Continue, Dr. Joe.
Oh. Okay. All right. Thank you. All right. So associated, meaning linked to each of the figures, we have some information about the number of dots. All right. I'm seeing another message in the chat. I'm not sure if I should check it there or not. I'm tempted just to see.
No, you don't need to. They're just responding.
Okay, we're good. Okay, we're good. So we're doing some records keeping here. We are mathematicians. We need numbers. We need information and data. Good. So for each figure, we have a certain number of dots. All right, so let's take a look at the first figure to see if we can find a connection somehow. All right, so for the first figure, could somebody tell me how many dots we have?
5.
5 dots. All right. So the first figure, which I call, as far as I'm concerned, that's the first term of my figure sequence. All right. So my first figure has 5 dots. Okay. So now, How many dots does my second figure have? And how were the dots created in the first place? How did I add more dots to it? By doing what? I added a circle outside, and then I did what? Added how many dots?
4.
4.
4 more dots, north, south, east, and west, to give you how many?
9.
9. That's what the table says?
Yes,
For
sir.
figure 2? Lovely. All right. So when I go to figure 3, how many more dots do I add? North, south, east, west. 4 more to
4.
give you
13.
13. All right. And then for figure 4, you add north, south, east, west dots, and that give you 4 more, which is 17. Okay. Lovely. So that means that in order to obtain the number of dots, I take the previous number of dots in the previous figures and add 4 more to it. All right. So the question here is, how many dots will figure 5 have?
21.
21. How did you obtain 21? What did you do to get
Sir,
21?
add 4.
One at a time. Just one at a time. Who
Sir,
wants
add
to go?
4.
Add 4. Okay, so
Sir, add
everybody
4.
agrees. All right, so add 4. So when you add 4 to 17, you get 21.
21.
Good?
21.
20. Okay, 21. All right. So something that is a bit more tricky to do would be to obtain a general n expression, which would mean basically come up with the nth term of the sequence. All right. So here's something that, well, different people will probably come up with this a little differently. All right. So I want to somebody to give me a suggestion as to how do I generalize, meaning how do I come up with the general pattern to get a formula for the number of dots based on n.
So you would
Sir,
times 4 by
Chris,
the figure.
let's hear Chris. Could you start over? Sorry
So
about
you would
that.
multiply 4 by the figure number and plus 1. So the
Why
formula
plus
would
1?
be, so if we said 4 times 1 plus 1 we get 5. So and 4 times 2 plus 1 we get 9. And continue.
Okay. So what you're saying is that you're starting with 1.
Yes, sir.
So you're starting with 1, which would mean something like, it's almost like you have a figure 0, which had 1 dot. That's how I'm processing what you're saying. I might be wrong though, if that's not the way that you look at it. I'm wondering like how you got the 1. Like why you start with 1 in the first place.
Well, sir, we are trying to find the number of dots. So,
So you start with a 1, and then you say, okay, to start the pattern, you say 1 plus 4, give you 5.
yes, sir, because we are trying to get back the
Sir,
numbers.
formula 4n plus 1, sir.
4n plus 1, yes. But the reason why I'm asking about this is it's not the same form of the formula that I got when I did it. They're both correct, but what you will find is that mine has things in terms of n minus 1 instead. All right. So the answer there, based on what you say, tell me if this is what you're saying, if that's correct. Is it 4n plus 1?
Yes, sir. That
Yes, sir.
that can one, but I prefer put it 4n plus 1. Me not write mine, sir.
No problem.
Oh.
We have something in mathematics called commutative, which means 1 plus 4n is the same as 4n plus 1. All right? You may not like one way versus the other, but they're both equal. All right? So I can write it back as that, but no problem. So just checking quickly in the chat. From Kim, previous term plus 4. Okay. So previous term plus 4 is another way to look at it. But the way to describe the general previous term is to start from, let's say, 1, and then you recognize a pattern that in order to get 5, you say you needed to add 4 in the first place. All right? So All right. So for each figure number, which is n, the number of dots has to do with a multiple of 4, but then started from some, let's say, basic value of 1. So that's one way to look at it. All right, let me just erase something here to write it in the way that that is preferred for n plus 1, right? All right, so let me just write back this as 21 for n plus 1. All right, cool. So what about the area of the largest or the outer circle? So after we finish this and hear from you guys, I'm going to show you what I came up with. All right. So the area of the outer, which is the largest circle. So what is the area of a circle, by the way? If I say the radius is r, somebody remind me. What's the area of a circle that has radius r?
Pi r squared.
So the area, which is A, is equal to pi times r squared, correct? So if the
Yes,
radius
sir.
is 1, if the radius is 1, what would the circle be, the area be?
1 pi
1 pi, which is pi, right?
or just pi. Pi.
So good. So the question says that the radius of each new circle is 1 unit greater. So that means that the area of the second circle has another type of pattern that we need to take into consideration because the radius is now 2. All right. So, all right. So let's take a look at the table and see what the table has to say about that. At least the first few figure areas, meaning the areas of the largest circle. So when n is 1, that's how I look at it. The area is pi. All right. When n is 2, what's the area now?
4.
4 pi. Okay.
4.
When n is 3, what do we get next?
9.
9.
9 pi.
9.
Good. Okay. So anybody seeing any pattern here in terms of how this is evolving, meaning how this is increasing or how this is changing?
Sir,
Sir, I think I
figure
number figure
yes,
number
sir.
times
Number of
2 pi.
figure.
What's that?
Figure number times 2 then pi.
Yeah.
Hold on. Just give me a second. All right. So 1, 4, 9, 16, 25. All right. So when you have n, so a very quick question that I can ask you is, if the radius of the circle is 1 more than the radius of the previous circle, isn't n the radius?
Yes, sir.
Something to think about. All right. So Marianne is asking, is there a case where we square the figure number? Okay. So you're onto it. All right. So instead of pi r squared, what do we have then? Pi what?
Pi n squared.
Pi n squared. All right. So that's a good way to look at it. All right. So pi n squared. All right. So pi n squared gives you that particular figure number. I have a feeling like when I was doing this question, I got it wrong. I'll take a look at it when we get there. All right, so I can get things wrong too. Let me take a look. I don't remember getting this number. So let me see. All right, so pi n squared. All right, because n really in this question is the radius of the circle, of the outermost figure. All right, so let's test it out. When n is equal to 3, what do I get? 3 squared, right? Which is
Yes, sir.
9 pi. All right. When n is equal to 4, we get
16 pi.
16. 4 squared, 16 pi. And okay, n equal to 5, the last one, we get 5 squared, which is 25 pi. All right. Okay, good. All right. Anybody has any questions about this one? All good? All right. No particular questions so far. All right. So now this one here is, I wonder if it's more tricky. Let's find out. The area of the shaded region now. So that is something like when you take away the area of the bigger circle minus the area of the smaller circle or the smaller circles inside. All right? Or the previous smaller circle. Let's see what the pattern looks like here. For the area of the shaded region, let's look at the numbers, which really has to do with the numbers in front of pi. All right? So as a matter of fact, without forgetting it completely, we can even ignore pi for a minute. All right? But we have to remember to put it back when we need it. All right? Let's look at the coefficients. Pi itself has what coefficient? What's in front of it? Without it actually being in front of it.
1.
1, good. So pi is 1 pi. All right. So when n is 2, what do you get?
3 pi.
3 pi.
3 pi.
3 pi.
Good.
Sir, what about
After
2n
that
minus
is
1? Oh,
2n minus 1.
yes, sir. That make it.
So what kind of number is 2n minus 1? How do we know 2n minus 1? What kind of number is in front of these? 1, 3, 5, 7. What's the next one in if we continue the pattern there? 1, 3, 5, 7.
9.
9.
9 pi.
9 pi. What kind of numbers are these? That's what I want to know. 1, 3,
Odd
5, 7, 9.
numbers.
Odd
Odd
numbers.
Odd
numbers.
numbers.
Good. All right. So we know our odd numbers, right? And odd numbers can be written in the form of 2. What is it? Somebody said it a while ago.
2n plus 1
minus
2n plus
minus
1
1.
No, sir.
or 2n minus 1, depending on where you want to start. So the thing
Yes.
is, if you say 2n
2n
plus 1,
minus 1.
could you repeat? Sorry. See, I was talking the same time. Sorry about that. Just repeat what you were saying.
2n minus 1.
2n minus 1. So what is the advantage of saying 2n minus 1 rather than 2n plus 1? What would happen if you did 2n plus 1? Would there be a problem in the formula? So I'm going to just put 2n, and then let's see if it's minus 1 or plus 1. So something to think about, everybody. If I had 2n plus 1, all right, what would happen when n is 1? What number would I get? What number would I get there? Which odd number would I get first? If I say 2n plus 1. Meaning, if I were to put, let me try to write it on the side. If I were to put n equal 1, and then I say 2n plus 1, what number would I get? Would I get 1?
3.
Sir,
You
get
get
No,
3.
sir. Sir, that would work.
3.
So right. So with the plus 1, although that is a valid formula for an odd number as well, the thing is that when n is 1, you'll miss the first one, the true odd number, which should have been 1. So that means you're missing you're two steps too far ahead. Let's put it like that. You miss one of them if you say 2n plus 1. So in order to get the missing one, you have to go back a little bit to 2n minus 1 to get the previous one to know what to start with. All right? So what you want is that when n is 1, the expression for the odd number gives you back 1 pi, 1 with the pi in front of it or after it. All right? So that is achieved by saying 2n minus 1. All right? And then you can put your pi afterwards, because although we ignored it for a bit, we have to remember that that's part of the formula for the area. All right? So we have 2n minus 1 in brackets, and that's important that the brackets are around the 2n minus 1 to say the odd number is the whole odd number, 2n minus 1 in brackets, is multiplied by that pi. All right? So this would be the pattern that is identified here for the area of the shaded region. All right, and we can do that based on the table. All right. Now, the one that is, I think, may not be so easy. Let me see if there's a problem with this one now. The total length of the circumference of all the circles, if you add up the circumference of all the circles in each figure, so meaning for figure 1, it's just the circumference of the first circle. In figure 2, it's the circumference of the inner one plus the outer one. All right? Figure 3, it would be the sum of the circumferences of the inner, the next inner, and then the outer one. And then you keep doing that. All right? So what would the pattern be here? That one is not so straightforward, but we can still do it. All right? So one thing that would help would be to look at differences between the numbers. All right? So going from figure 1 to figure 2, we go from the total length circumference being from 2 pi to 6 pi. All right? So what is the difference between 2 pi and 6 pi?
Sir, 4 pi.
So the difference is 4 pi. So I'm just going to put the number 4 for the difference between them. All right? So what is the difference between the second figure number and the third figure number? So I'm seeing a suggestion from Amara, 4n minus 2. I'd have to get back to you. All right? Just remind me of that one, right? 4n minus 2. There might be something to that. All right? Right. So I'm going to go back to asking the question, right? We'll get to that 4n minus 2. I find that interesting. All right? But based on the differences that we have here, so the difference between the first figure number in front and the second finger number in front is 6 minus 2, 4. Right? I'm ignoring the pi for a little bit. Right? What about going from the second figure to the third figure? What number do we have in the difference? What's the difference between the two? 6. All right. So we have a 6 in there. All right. What's the next difference?
8.
8. All right. So the reason why I am highlighting that is that the difference between the two values are not constant. It's not a constant difference. It's not the same difference all the time. All right. So we have to bear that in mind when we are coming up with the formula, that the difference between them is increasing by 2, or you can say by 2 pi all the time. All right. So bearing that in mind, I'm trying to find a pattern here. So if I go from the first figure to the second figure, I need to add 4 pi to get 6 pi. If I go from the second figure to the third figure, I need to add what? 6 pi. All right. If I go from this third figure, which is this, has this number, to the fourth figure, I need to add what? 8 pi. All right. So the question is, what do I need to add to go from the fourth figure to this missing number here? What do I have to add? I have to increase the difference to what?
10.
10.
So I have to increase it by 10 to give us what? So what would the number be here then?
30 pi.
30 pi. All right, lovely. Now, the trick or the tricky situation now is, how do I generalize all of this so that I can account for the fact that the difference is increasing? That's where it's a little fun, a little strange. So my question is, so let's go back now to Amara. So does 4n minus 2 do it?
No,
So wait, so when you were saying 4n minus 2, so what were you thinking about there? When you say what was the 4n minus 2 about?
the two first figures.
Mm-hmm.
Yeah.
Okay, the two first ones would have been probably 4n minus 2, perhaps. All right. And then the second to third, that means that the 4 would have turned to a 6. So that means that that number that you have there, the number 4 is not constant. That one is the one that has to change as well. All right. So Kemoya is saying n times n minus 1. Would that work? I wonder. I wonder if that actually is going to be the one that works here. Let me see. So when n is 1, I'm going to write down your suggestion, Kemoya. All right. So n, as soon as I cut off the chat, I forgot what it was. N times n plus 1. Let me give that suggestion. All right. Let me give that a shot and see what would happen. N times n plus 1 pi. All right. So test it out for me and tell me if this is all right. So when n is 1, does it give you the answer? 1 times what? Anybody? When n is 1? Somebody walk us through it.
Yes, sir.
1 times what?
So 1 times 1 plus 1 plus pi.
So 1 times 2
Yes,
times
sir.
pi, which is 2 pi. That's all right.
Yes.
So next one now, when n is 2, you get 2 times 3, which is 6 pi. Okay, good. When n is 3, you get what? 3 times 4 pi, which is 12, right? 12 pi. When n is 4, you get 4 times 5, which is 20. Okay. Then when n is 5, you get 5 times 6, 30. All right. So this seems to be correct. All right. So this seems to be okay. Why did my thing here work all that? Hold on a sec. Let me see. See if I could erase this little piece here. All right. So this seems to be correct. Now my question is, Kemoya, how did you come up with that? What's the thought process? Was it intelligent guessing to see to get that formula, or did you have a system to think about it? I'm curious. Are you willing to unmute your mic and just give you a little run through as to how you got that, the n and the n plus 1 times n plus 1? Or you can even put it in the chat if you're not in a position to unmute. I would love to hear how you would have what you would have thought about in terms of coming up with this product n times n plus 1. Okay, so until then, let me see what foolishness I came up with. Let me see. So I should be able to go to the next formula. Oh, wait, one sec. Let me see what's in the chat. So n plus n squared. Okay. All right, n plus n squared, which would have been, well, I know, well, the expansion is n plus n squared, but I'm wondering why n squared? Like where would that have come from? In terms of maybe the circumferences or the length or something, like, is there something else that was going on to get n and then to get n squared? All right. So let's see what I would have come up with. And let's see if we can figure out what is going on here. Hold on, let me see something. So this here, for example, most likely this here is incorrect. The third one with the area of the shaded region. All right. So you guys would have gotten the correct answer there. Most likely. Let's see. Well, no, not that one. This one here. This one, no, this is okay. All right. Let's take a look at the first one here, which is the number of dots. And let's compare it with the 4n plus 1. Are they the same number? The same expression rather? Do they work out the same? So you guys would have suggested for the number of dots, based on the adding 4, that you would have gotten 4n plus 1 as the expression, and it works. All right? So why do I have this more complicated looking expression? 5 plus 4 times n minus 1. Does this one work? So when n is equal to 1, this part goes to, this n minus 1 is 0, and then I get 5, which is the first figure, number of dots for the first figure. So does it work out? So when n is equal to 1, I get 5. All right. When n is equal to 2, I get what? 5 plus 4 times 1, which is 9, etc. All right. So it's the same idea that I'm adding 4. All right. Anybody has any questions for me as to how I came up with this rather than the previous one, the 4n plus 1? I mean, what you guys suggested with the 4n plus 1 is correct. All right. But how is it that I'm getting the same answers working out here with my expression? Anybody has any questions about the expression, the one that I came up with? But it's okay with it? Not sure how I got it. Everybody is looking carefully at it, silently.
Sir, how I use 5? Because,
Well, the simple reason why I use 5 is that the first one has 5. That's really the only reason. I started with 5 because the figure number 1 has
okay.
5. Yeah. Now, the
Okay.
question is, the reason why I have n minus 1 is that I wanted that when n is 1, I still get back 5. So when n is 1, the only way I can still get back 5 is if there is no adding of 4 when n is 1. That's how I look at it. So I start at 5, and then I do not add 4, which means I add 4 times 0 to give you back 5. That's the only reason why I put it like that. All right? So I'm just suggesting to you guys that there might be a little different way of thinking about it, depending on how you construct it. All right? So I wanted to hear from you guys to see how you guys would have come up with it, and then maybe propose to you what's another possible way of coming up with a formula. But the formula is the same, it's just written differently. Mine is more complicated for no reason. All right, I'm Sheldon. So I'm reading from you in the chat there. Horizontally, when you look at the figure number and the area of the outer circle, the sum gives the last column. Hold on. When you look at the figure number, okay, and the area of the largest outer circle, okay, the sum gives the last column, yeah. Yeah. Let's see. The sum gives the last. Okay. Okay. Well, to an extent. I understand what you're saying with it. Yeah. To an extent, yeah. Okay. So there are different ways of coming up with the formula. Some might be simple, some might be more tricky. All right. So I just wanted to show you this one here. All right, to say that there are different ways of doing it. All right, now the area part, I decided to take a very, very complicated route. So I would not recommend that you do it the way that I do it here. All right, the easiest way for you to go about that area of the outer or the larger circle is just to recognize that the area of a circle is pi times something squared, right? And then just notice that what's being squared here is the number in front of pi. So you have 1, which is 1 squared. You have 4, which is 2 squared. You have 9, which is 3 squared. 16, 4 squared. That's the easiest way. All right? And that's the way that I would recommend. All right. So this way that you guys came up with there, that is the recommended approach. So the simpler, the better in getting answers. So the bunch of complication that I came up with here, I had my own thought process as to how, but there's a much simpler way that you guys showed me in terms of coming up with it. It's simple enough to just say 2n minus 1 pi rather than all of this that I have here. All right? So you don't need all of this. All right? So just identify the pattern according to how you get it, and then it would be fine just like that. All right? Any questions here? So the question is, why are you doing a January paper when you are doing May, June? Because maths is maths. That's a simpler question as I would think about it. Maths is maths, and in the sense that when you do patterns and you do these things, they would still be helpful in your preparation to do a January paper. All right, whether you do it in January or whether you do it in May, doesn't change the mathematics that it came from. All right, so they are all going to be helpful for your preparation. Good? All going to be helpful for your preparation. Good. Okay, so I am seeing that it is now very close to 7:30. Which means that we are very close to being out of time. I know that we had started a bit late. So I'm going to ask Mrs. Johnson Burrell if it is okay to continue a little bit more, or do we have
Can Dr.
a
Job, you
particular time?
can.
Right. Okay. So I also would not be able to go on for very long, but I would be able to go on a little bit more because I at least wanted to touch on one of the other papers, right? And some of the other things that we were talking about. So there is this question here, which is part of it as well, to determine the value of n, all right, for which the number of dots in figure n is 541. All right, so I would have answered this question based on my formula that I came up with, but I'm pretty sure that with your new and improved formula, the one that is better than mine, for n plus 1, you will get a much simpler calculation. All right? So from the formula, which is a sequence formula for the number of dots being 4n plus 1, all right? We can equate that very similar to what we did in the first set of questions that we did, all right, in order to get a value of n, which is like saying finding the nth term of the sequence that gives you a particular value as an output. So determine the value of n when the number of dots in figure n is 541. So in answering that question, we bear in mind that the number of dots, all right, is equal to what? So the number of dots, which is in terms of n, would be given by the sequential formula that we had previously, all right, which is what? 4n plus 1, all right? So what the question is asking is, what happens when the number of dots is 541? What do I have to equate then? What's the equation that I will come up with? Anybody?
4n plus 1
4n plus
equal
1 equal
541.
541.
Lovely. So 4n plus 1 is equal to 541.
41.
All right. So if 4n plus 1 is equal to 541, what can I do with this information to get
So you
n?
can sub,
You're
so you
going
can
to minus one
sub,
on both
Minus
sides.
1.
Subtract n on one on both sides.
Good. So we get 4n is equal to
540.
540, right?
And now you
541
divide
minus
by
that.
4.
All right. So n is equal to 540 divided by 4, which is equal
Which
to
is
what?
135. 135.
135. All right. Okay. So 540 divided by 4 is 135. All right, so let's see. So I did it a little differently. And because my sequence, my expression, the sequence, the expression is the same, that I got, but it looks different. All right? But it's the same answer that I got, 135. It's just that the calculation is different because of where my formula started from. All right? So we got 135 the same way, right? It's just that the working was a little different. But I actually prefer this calculation based on what you all would have suggested here for this pattern sequence for n plus 1. It works out a lot nicer than what I would have come up with. All right? So good job, guys. I really appreciate the 4n plus 1. Much nicer. All right. So any questions about this calculation here, this working? So what this means is that in order for us to have a figure with the number of dots being 541, we need to draw how many circles? 135 circles and put north, south, east, and west on each of them. That's what this tells us basically. All right. If I wanted to create a figure like what we have in the pattern so that the total number of dots is 541, that n is the number of circles that I need to draw. Right? Effectively, is the number of circles that I need to draw with north, south, east, and west on each of them, and then the dot in the center. Right? So I have 135 circles to draw. All right? So that would be very useful for, well, art in some sense and a lot of different types of pattern recognition type of things, image recognition software and stuff like that. All right. Okay. So any questions here? Any other questions? No questions? All right. So this one here, I'm not going to bother with right now. However, I'm going to put the formula for it. So this is a substitution type question. All right. So in favor of another thing I wanted to go through, I'm going to just skip this one here. All right. But if you would like to see what this solution is all about, we can probably arrange to get these types of solutions afterwards. All right, but let's take a look at quickly at a part of a June 2022 paper. All right, so this one has to do with an arrangement type of question. All right, so it looks like I was hired or we were hired as a wedding planner, for example. All right, so we are part of a wedding planning company, and I want to know how best to arrange a wedding hall, all right, for the wedding reception, all right? And there are two different ways with which we can make this arrangement of tables to seat a certain number of people, all right, around these tables. So we have arrangement L, all right, which is follows this particular pattern that we're adding a table and chairs in a certain arrangement. So we're adding joining the tables together based on length. So length, well, not lengthways, but we're joining the lengths of the tables together and then adding chairs around them in this type of pattern way. Or we can arrange it in a different way where we add the tables together, join them in terms of the width of the table, and then put the chairs around them. All right. So based on this, on these diagrams or sequence of diagrams, the first question is to draw the diagram for 4 tables using arrangement L. All right. So what you would notice is that from the first table, one table arrangement to the pattern sequence to the 2 table, we basically took out these 2 chairs to give room to join these 2 tables in this way. And then I put these 2 chairs basically over here. All right. And then I put 3 more chairs along the other table. That sounds more or less like the pattern. All right. So if I were to add another table onto it, I do the same kind of process where I take these 2 chairs. That's how I look at it. All right, move them out of the way. All right, and then I add this next table onto it. All right, and then I put these two chairs right here at the end, and then I bring in three more chairs to go on that side and three more chairs to go on that side. So it looks like every time I do it, I need to add six um, different chairs each time. All right, looks like that. All right. But the question is really to extend the joining of the tables to a fourth table addition. All right. And I think you guys would agree with me here, at least for arrangement L, which would allow you to join it now based on the length. You're doing a similar thing where you're taking these three, you're moving it out of the way. You're eventually going to put it back here. All right. But you're going to add two different chairs, this one and this one, every time you do it. All right. So my arrangement that I came up with was this one here. All right. If I add a fourth table onto it for arrangement L, all right, then the arrangement for four tables would look like this. All right. Anybody has any questions about this one?
No,
Seems
sir.
sensible, reasonable? All right. Okay, so one of the questions that is even more formula driven, which I'll get to in a little bit. All right, not even this one right now, although it's not so difficult to see the pattern here. All right, so we can just look at this quickly and see that for arrangement L in the table, every time I introduce a new table, how many chairs do I have to add onto it in order to keep the same type of
Four.
figure, right? Four more. So if I have 10 for one table, 14 for another table, 18 for another table, then what's the next one?
So 22.
22. So this one is going to be 18 plus 4, 22. All right. What about this one now? For arrangement L, for arrangement M, how much more do I have to add? Number of chairs do I have to add each time? So 10 to 16 is how many? I'm seeing some messages in the chat. Let me just take a quick look. All right, so Kemar is saying 6. All right. So 10 to 16 is 6. When you add another one, you get 22. You add another one and you get what? 20. Would it be 28?
28, sir. 28.
28. All right. Now, here's the interesting part. So we go dot, 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 and we get 130. All right. Can we figure out from an arrangement, within arrangement M, having a number of chairs 130, can we figure out what number of tables this corresponds to? That's a very interesting question. How many? Somebody got the answer ready? Okay, probably I misheard. So this is a very similar question. I hope that you guys are recognizing the pattern, not only that the question is asking you about, but I hope you're starting to recognize a pattern in the way that some questions are being asked. That some questions are asking you what number of, let's say, tables gives you a certain arrangement, which means solve for, well, in this case, T, but it almost looks like solve for N, like a sequence which keeps going over and over in terms of how I look at it. All right. So if I want an arrangement under arrangement M with 130 tables, I might want to know what number of tables do I need in order to get 130 chairs around them. All right. So that's another solving thing where we get an equation. But in order to get the equation, I need to get the general formula for the number of chairs for arrangement M. Could anybody suggest a general formula in terms of, let's say, number of tables? Well, T or N, whichever one. I guess T because that's what was given. All right, that means I didn't follow instructions properly. It should have been T. But anyway, I think I would have put N. All right. So what is the general formula here that can be identified?
Sir, 6 times n plus 4.
Sir,
6 times
N plus 4.
n plus 4. Okay, so 6n plus 4. Okay, all right, fair enough. Now, similar to how I did it the last time, I would have started with 10 and did some kind of n minus 1 in brackets thing. But this works as well. All right, so 6n plus 4 works. So the question then comes back to the 130. If 6n plus 4 or 6t, which really it should be here to be more faithful to the question, right? It really should be 6t plus 4 if we're answering the question appropriately. All right. So 6t plus 4. All right.
Sir, could you go over this? Oh, you got the 6n plus 4.
Okay, so would the gentleman who suggested the 6n or 6t plus 4 just give a quick explanation, a quick run through as to how you got that? Was it Kimar?
So, sir,
Oh, Chris, all right.
so like how we know the difference for the number of chairs is 6, sir, because 16 minus 10 would give you 6. And 22 minus 16 would give you 6 also. So you multiply the 6 by the number of tables, which is n. And you add a certain number to get 10, which is 4.
Okay, all
And do it for
right.
the rest of them, sir.
Okay, so you follow that explanation?
No, sir,
Yeah.
I still don't understand.
Didn't
That
quite
is making
understand
me
it?
more confused.
Okay,
Oh,
so
you
that's
got the 4.
okay, okay. So okay, I understand. So with one table you get 10, all right? But it's by recognizing that the pattern was that there is 6 being added every time. All right? Um, in order to get what I call it something like an intercept. All right? Like if you're plotting a graph, you try to figure out what would happen if n is equal to 0. You have to take out 6 from 10 in order to get 4 to kind of get like an intercept in the function or in the straight line expression. That's a way that you can look at it. All right. So in order to know what would happen when t is equal to 0, you have to take back 6 from 10 to get from one table to the number 0, which would give you 10 minus 6 is 4. So that's a potential way to look at it. All right. I'm saying it knowing that that's not the way I did it, but I could understand that that's how somebody might think about it. All right. That with one table you have 10. So if you want to know what the zero value is, you have to subtract 6 again to go from 1 to 0, and that will give you 4 as a starting value. All right, that's one way to look at it. All right, does that make even a little sense?
So, sir, why could I take away 1 out of the 10 instead?
Well, every time you take away a table, you remove 6, or putting it in reverse, every time you add a table, you have to add 6 chairs to it. So if you were to take away a table, you were to take away 6 chairs from 10 to give you 4 to start out. All right, so that's a way to look at it, at least for arrangement, for arrangement M. All right, so as Mariana was saying, for arrangement L, it's what, 4n plus 6. So it's a similar thought process where every time you add a table, you have to add 4 chairs for arrangement L. All right. So that means that if you want to go from one table, if you follow the same trend, if you want to go from one table to 0 tables, you have to take away 4 from 10 to give you 6. So that is the starting, that's where you start the things from. And then each time you add a table, you need to add 4 chairs to it. So that means you have 4t plus 6. All right, if you apply a similar argument like what you did for the other arrangement. All right. So somebody had gotten 28 for that. Is that, what was that? Is that Kemar? Kemar, yes. So you got 28. That's for the number of tables corresponding to 130. That's confirming. Number of tables, 21. Okay. All right. So going back to this thing of 130. If I wanted to know how many tables gave or in arrangement M is associated with, is associated with 130 chairs. Why does this keep doing that? Hold on. Let me check something. Hold on. Looks like something is not, all right, activating properly. All right, good. All right, got it back now. So if we set this 130, all right, and I want to find out how many tables can have an arrangement associated with 130 chairs in arrangement M, then that will give you the value of T to put right here. All right. And then from that now I can figure out what to put here in arrangement L. All right. So the value of T here, and you guys can tell me how to solve this equation, this linear equation. So it's 60 plus 6 times T plus 4 equals 130. What do? I subtract 4. So 60 is equal to what?
126, sir.
How many?
26. Sir, 126.
126. Okay. What's 26 divided by 6? Is that the 21?
Yes, sir.
Yes, sir.
Okay. So that means right here, I'm going to put 21. All right. And now based on this formula right here, and I think we're going to have to stop at this point. All right. I can use the 4T plus 6 for arrangement L now to figure out what number of chairs with 21 tables I am to put in this position right here. All right. And so what that will give me is 4 times 21 plus 6, which gives you what?
90.
90. All right. And that's the number that we put right here. All right. Okay. So that's unfortunately all the time that I have for this evening. All right. And I would like to thank you all for the beautiful interaction, all right, that we have had in answering these questions. All right. And I would like to encourage you guys to continue your practice, continue your preparation. All right. And all the best in your examinations when they do come around. And so I would like to hand back over to Mrs. Johnson-Burnett.
All right, students, you know the drill. Let's give sir some thumbs up, some hearts. Let's thank sir for really staying with us this evening.
Thank you. Thank you.
We really want to thank sir for everything that he has done this evening with patterns, sequences, and series. And we want to thank you too for being here, because if it wasn't for you, we would not have been here this evening. Please remember our final session will be on Thursday. That's the day after tomorrow. That's May 7. We know the exam is next week, Tuesday, and we kind of want you to get a little break. We know you still won't officially take a break, but still get a little break from the virtual sessions. So our final CSEC math preparation exam prep workshop will be on Thursday, May 7, and this will be on measurement. So even if you are good with measurement, still log on. Who knows? There may be a question, there may be something about a question that our next facilitator will work through that will better help you. All right. And also remember that it's math, whether it is in January or May or June, whichever month it is, we are really looking on questions to kind of sharpen up our skills. Okay, students, so thanks so much being here this evening. Remember, if you want to watch the recording for this afternoon session, as well as the sessions that would have gone before today, you can just go to Region 7 Mathematics Team YouTube channel, and all the videos are there. Thanks, students, and all the best. See you on Thursday, May 7 at 5:30 p.m. Take care. Thanks, Dr. Job.
Yes, and thank you for having me. Thank you for the invitation. Really enjoyed it.